So let us discuss a problem on balancing of rotating masses in the rocket plane. A shaft carries four masses A, B, C, D of magnitude 200 kg, 300 kg, 400 kg, and 200 kg respectively, which has got a revolving radius of 80 mm, 70 mm, 60 mm, and 80 mm in planes measured from A at 300 mm, 400 mm, 700 mm. So these are all the distance. Angle between the crank measured anti-clockwise are A to B 45 degree, B to C 70 degree, and C to D is 120 degree. The balancing masses are placed in the planes X and Y. The distance between plane A and X is 100 mm. Between X and Y is 400 mm. Between Y and D is 200 mm. When the balancing masses revolve at a radius of 100 mm, find their magnitude and find their magnitudes and angular positions. So here in the problem, he has given the data, but where to place the balancing masses which has to be placed. Here he has specified. So initially construct the space diagram. So the space diagram here you can see A, B, C, D mass is given. So X and Y are the two planes where he is going to place the balancing mass. Here X is taken as the reference plane, which is at a distance of 100 mm, and for Y it is at 400 mm. So A to B it is 300, A to C is 400, A to D it is 700 mm distance. So MA to MB it is 45 degree, MB to MC it is 70 degree, MC to MD here it is 120 degree. So here you are supposed to find out the what is the balancing mass in the X plane and its orientation. So construct the tabular column after space diagram. So here mx is unknown and radius is given, my is also unknown and distance radius is given. So construct the centrifugal force, measure the distance from the reference plane and calculate the couple. Centrifugal force and couple values are required. So in the tabular column, if you see zero point 0.1 of mx, 0 point 0.1 of mi are two unknowns. So in the couple 0.04 of mi, it is only one unknown. So based on this value, you are supposed to construct the couple force polygon and the couple polygon. So this is the initial diagram what is supposed to construct. So when you construct the force polygon, so here suitable scale is selected. So here 16, 21, 24 and 16 and zero point 0.1 my it is drawn because it is a known. So with respect to the point E and point O, here is supposed to join the lines, so that gives the balancing force. Here it is 0.1 of my, 0.1 of mi it is there, 0.1 of mx is there. So measure 0.1 of mx with respect to the given scale. So it is 0.1 of mx, you are going to get it as the balance force. But when you come to the couple polygon, here uh, minus of 0.1 mx. So if you go to the previous slide and come to know, minus 0.1 of ma into x, but this orientation it is given. So first distance is minus 1.6 is there. So next 4.2, 7.2, 9.6, balance couple 0.04 of mi are going to get 0.04 of mi. Here we are supposed to measure this distance and find out my. It is 182.5 kg, and the corresponding orientation with respect to point Y it is 12 degree. So like this you'll be able to find out the required mass my. So here uh, in the force polygon, vector OA is 16, 21, 24 and 16. So 0.1 of mx if you take, and measure the distance, you'll be able to get 352 kg. 352 kg and the orientation is 145 degree. So like this, you'll be able to solve the problem. So in the present problem, we can see there are four masses A, B, C, D. So here mass A is unknown. So out of the four given masses, I suppose to select one reference plane. All the four radius is given. So here the first mass itself, it is taken as the reference mass. We will construct a tabular column. So deciding the reference plane, it is very important. Instead of taking the A as reference plane, you can take as B. So you're supposed to see that there is a rule that the sum of the resolving forces towards left and right, we are supposed to consider based on the symbolic representation. So if you take A, remaining it will be positive. If you take B, A will be negative, C, D will be positive. So mass A it is unknown, mass B it is 30, mass C it is 50, mass D it is 40. So radius, all the radius it is known. So only mass A it is unknown. So you construct the force polygon, and the force polygon for 7.2 OA, OB is 7.2, BC is 6, CD it is 6, so D point join the point O, it is zero point 0.8 of MA, that comes 56 degree. So 56 plus of 180 if you take, so the required angle it is achieved. So mass A, if you take with respect to the measurement, 3.6 is equal to 0.18 of MA. So mass MA it is 20 kg rotated. So on the orientation overall, if you take, it is 236 degree. So like this, you'll be able to compute the, with the help of force polygon, the unknown mass is found out. So here mass MA it is found out. So further going with the couple polygon, if you take here, there are two unknowns. So here, by taking a suitable scale, 1.8 it is taken and the remaining two values are unknown. So you can construct with the help of triangulation method. So at last you'll be able to get C dash D dash O dash D dash. So so measure the corresponding distance. So vector C dash D dash is 4.6 centimeter. So convert it into the required scale, then Y it will be 0.383 meter. So and the X, if you take, if you measure point minus 0.186 of MA into X, so you'll be able to get 3.6 kg per meter square. So X you'll be able to get 1 minus of 1 meter. So like this you'll be able to get the solution.